We've been talking for a little while about these special factoring patterns, and over the last couple weeks, we were working on sum of squares and difference of squares, and we worked through those and did a million of them. Well, I thought we'd move to something new today, and that's sum of cubes. And what that suggests is that if we have this cube plus this thing cubed, it can be factored out, and the two factors will be a plus b times the quantity a squared minus ab plus b squared. We're going to see difference of squares today also, so I don't want to beat this drum too hard, but I want you to remember that the plus sign here reminds us that there's a plus sign in the first term here, and there's a negative sign in the second quantity here, okay? Okay, so moving on, let's just take this really quick example, and we want to factor x cubed plus 27. Well, x cubed is a perfect cube because it's x times x times x, right? And 27 is a perfect cube because 3 times 3 times 3 equals 27, doesn't it? So that's a perfect cube. What I want to do here is just try to isolate these values. What is the value of a? And is to say what number is cubed? Well, in this case, it's x. X is the number being cubed. People get really, really confused, and this is where a lot of mistakes happen, is that they look at this number here, this 27, and they say, oh, 27 must be b. No, the question is, what number cubed? What number cubed? What number raised to the third power is 27? And therefore the value of b is 3. Why? Because 3 raised to the third power, 3 times 3 times 3, is 27. If you look at it here, 3 cubed, if we did this arithmetic, 3 cubed, we'd get back to that, wouldn't we? Okay, so just something to think about. So we're going to go from there. It's just going to start trying to apply this rule a little bit. And we say, okay, we recognize we have the sum of cubes here, and we recognize this rule up at the top. So I rewrote the rule. And now I'm going to take, right, this is going to be really helpful if you list these things out. So before you start working on the problem, just make a list. Can't tell you how many calculus students I beg to make lists. So I'm begging you as my algebra students to also make lists. So make a list, please. So then I'm going to take my list here. I'm going to fill in the blanks. It says A is X, so where there was A, I put in an X. I said B is 3, so where there's supposed to be a B in the formula, I put the 3 in here. If you see the green parentheses, what I'm doing is I'm satisfying this up here. And in the white, I'm satisfying these parentheses up here. I'm just filling in the blanks here. So it said the second thing is that I have A squared. Well, A is X, so I have X squared. Next thing it says I have the opposite of A times B. Well, the opposite of A is negative X times B is negative 3X, right? And then lastly we have, it says we have B squared. Remember that B is 3, so 3, whoa, that's not a 3. So that's a 3, isn't it? Not a good look. But 3 squared is equal to 9, right? So that's where I got this 9 from, okay? So I'm going to go over this a lot. Don't freak out yet, but hopefully take a second, stop the video, go back and check this out. And then as you figure it out, play the video back again. And as I assign you homework, I hope you'll use the video. It's just a little bit of supplemental help on this stuff, okay? So here we're going to use this second rule that we're going to discover. But while we're doing that, I'm just going to put this little bit of extra thing on here. It's not too bad. It's actually a really cool skill to have. It's factoring out the greatest common factor. So I give you this thing as a factor completely. And this looks horrible. It says y is equal to 16u to the 5th. Can you imagine? Minus 250u squared. And I look at that and I have to admit to you that I can't picture that graph myself. I mean, it's a mess. It's a mess. So what is the greatest common factor here? Well, I put the numbers in blue and I'm asking myself, what's the greatest common factor of 16 and 250? And I realize that the greatest common factor is 2. So I factored out this 2. I put the u's are in green and their exponents are in gray here. And what I want you to remember is we can only factor out the thing that they share, the smallest amount that they both have, right? So they both have 2. Can't factor out u to the 5th because this one doesn't have 5 factors of u. It only has 2 factors of u. So we're going to factor out 2 factors of u, otherwise known as u squared, right? And then I'm going to just do my math a little bit backwards. 2u squared times what gives me this back? Well, 2 times 8 gives me back my 16, doesn't it? Remember the rules of exponents. When you're multiplying these like bases, you add the exponential values. So u squared times u to the 3rd gives me back my u to the 5th, just checking to make sure I have everything done. going to go back here. Going to have 2 times negative 125 is in fact equal to negative 250, so I haven't lost anything. And u squared times negative 125 is negative 125u. I'm sorry, negative 250u, because right, we already used the 2 here to get that back, right? Sorry, that was a little bit confusing for me. Okay, so moving on. So now, I'm just going to rewrite this in an equal form, but it's going to look weird to you for a second. Remember, exponents are distributable over multiplication. So this is the same as saying 2 cubed, and 2 to the third power is 2 times 2 is 4, and 4 times 2 is 8. I have my 8 right here. This 2 to the third power is my 8. And of course, u to the third is, well, u to the third. Okay. Then I'm looking at this. I'm going to break this out. And isn't it true that 5 to the third power, this proved that 5 to the third power is 125. 5 times 5 is 25, and 25 times 5 is 125, okay? This negative sign is this one, so all is good. So hopefully now we recognize that we can use the difference of squares here, and here's where it gets a little bit messy, especially when you start messing with this. It gets kind of weird, but we can do this. Hopefully you can see that this is our a value right here, isn't it? This is our a value right here, right? 2u is our a value, and 5 is our b value, isn't it? Okay, so 5. So I'm just going to go in. This, remember, this piece right here, this 2u squared, is what is the greatest common factor we factor out. So that's just that, right? So this times this is going to give me this thing back right here, okay? So that's what we're getting to. And it says here that it is a minus b. Remember, it's difference of squares, so there's a negative sign here, and there's a negative sign here. We talked about this when we were talking about sum of squares. And then there'll be the positive sign here. It's just something you have to remember. The easiest way is that when difference of cubes, it's difference, difference. Okay. So it says that we have a minus b. Well, a is 2u, so there it is. b is 5, so there it is. This negative sign right here, you guys, is this one, isn't it? So this negative sign is this one right here. And then now I'm going to complete the blank over here, right? So we have, it says we have a squared. Well, a is 2u, and 2 squared is 4. U squared is u squared, so there's that, right? And then the middle part says that we have positive a times b. Well, a is 2u times 5 is 10u. Not bad, right? And then lastly, we're supposed to remember that the last term here is going to be b squared. Well, what is b? Right? It is, good, 5. 5 squared is 25. So we have that factored form here. I know this is a little bit weird, and I'm asking you not to give up yet. This is going to work out really, really well, but we just have to practice this for a little while. So please hang in there. I'm going to assign you work. Please look on yourhomework.com, and we'll see if we can't get through some of this. Will there be a snow day tomorrow? I don't know. Maybe.